Hey guys, we're back, and today in this video we're going to be covering the second half of section 3.2, which deals with elimination. Now this is another algebraic way to solve systems of equations. Last video we talked about substitution, got a lot of practice there, and so today we're going to do the same thing and work a few problems with this new method called elimination. So I've got a step-by-step on the screen, and so if you want to write it down, you can pause it and go ahead and do that. I'll be demonstrating all these steps, what I mean by line everything up in air quotes. If needed, step 2 is kind of an optional step depending on the problem. We can multiply one of the equations or multiple equations in our system by something to get matching coefficients. We'll add or subtract equations to eliminate one variable. That's where this method gets its name. And then the back half of this method is actually exactly the same as substitution. Once we have one equation with one unknown, we'll solve that, use whatever we get, plug it in to get our other variable, and then check our solution. So right here, here's the first problem we'll be looking at today. Negative 4x equals 2y minus 12, and 4x plus 8y equals negative 24. Now, step 1 says line everything up. And what I mean by that is we want the x's in both equations to be on the same side of the equal sign, the y's to be on the same side of the equal sign. We want the equal signs to be lined up, and we want the constant, just the number, to be on the same side of the equal sign. So what I typically do, just because I find it easy to go in this pattern, is I make it look something like standard form, ax plus by equals c. Now, I don't worry too much about the x's always being positive, things like that. That's not required for elimination. But I do just try to get, say, the x's and y's on the left-hand side of the equal sign and the constant on the right-hand side. So I'll go ahead and demonstrate that. So I'm going to take this first equation and maybe move the y's over. So negative 4x minus 2y, because we'll subtract it over, equals negative 12. And then the second equation is actually good to go as is because it has the x's and y's on the left-hand side and the constant on the right. So notice, and I'll erase these highlights in just a second, but the x's are lined up one on top of the other. The y's are lined up one on top of the other. The equal sign is lined up one on top of the other, and the constant is lined up one on top of the other. So that's step 1. Now, step 2 says, if needed, multiply an equation or multiple equations to get matching coefficients. That's actually not necessary in this problem. But what does that mean? For elimination to work, we need to have 2x's and 2x's in my two equations, or 6x's and 6x's, or even 5y's and negative 5y's. If the sign is different, that's okay actually, but the number, the absolute value of the number, you could think of it, that magnitude has to be the same. So notice that I have negative 4x's and 4x's. So we don't need to multiply anything. We are all set up for elimination. And we're ready to go to step 3. Step 3 says add or subtract. Now, one of these is correct, one of these is not. And what we have to ask ourselves, because we're trying to eliminate, in this case, the x's, is negative 4x's plus 4x's going to kind of cancel out and get us 0x's? Or should I do negative 4x's minus 4x's to cancel them out? And we think for a second, and then we say, okay, negative 4 plus 4 equals 0. So I want to add these two equations together. So I'm going to say add that entire second equation. Watch what happens. Negative 4x plus 4x, well, that's gone. That's our 0x's. We eliminated the x. Negative 2y's plus 8y's, 6y's. And negative 12 plus negative 24, so we continue going in the negative direction, equals negative 36. Well, now this is a pretty simple one-step equation to solve. We've got one equation, one unknown. I'll divide both sides by 6. Y looks like equals negative 6. So we're halfway to our answer. We've got y. We can choose either one of our original equations to plug into. So I'll just choose the first one, no real reason. But I know that negative 4x is equal to 2y minus 12. So negative 4x equals 2 times, if we accept that y is negative 6, minus 12. Well, let's see what this gets us. Negative 4x equals negative 12 minus 12. Negative 4x equals negative 24, which means divide both sides by negative 4. X looks like it equals positive 6. So we've got an x, we've got a y. You guys know I'm a big fan of checking my work, so I'm going to open up my calculator. I'm going to get to my main screen, second quit, and clear it out. I'm going to store 6 in x, as we've seen before. I'm going to store negative 6 in y, alpha 1. And then I'm going to kind of type in my equations. So first one is negative 4x, and I hit enter, so that's negative 24. Is that the same as 2y minus 12? Also gets us negative 24. So you can see on the calculator that first equation, when I plugged in both sides of the equation, they equaled each other, so that one's good. What about the second one? 4x plus 8y, does that equal negative 24? Yes, it does. So we checked equation 1, we checked equation 2, they both looked good. So I'm going to say x comma y equals 6 comma negative 6. Box it up, because we checked it, we know it's correct. So this is what elimination looks like. We're going to add or subtract equations together to eliminate one of the variables. In this problem, we eliminated x, but we could have eliminated y. And then solve for y's, plug it in to find x, check your answer. Let's look at another one. I'll keep the checklist on the screen for now. So we've got 1.25x minus y equals negative 7, and 4y equals 5x plus 28. Now, first steps first, we got to line things up. In this one, the first equation actually looks okay as far as having x's and y's on the left, so I'll keep it the same. But then the second equation, I'm going to move my 5x's over to the left just to line everything up. So negative 5x's, because I'll subtract it, plus 4y equals 28. So step 2 is the optional one. And in the first example, we didn't need to multiply anything because we had the 4x and we had the negative 4x. And so they were lined up and the same magnitude. On this problem, however, we have 1.25x's and 5x's, negative 5, I should say. So those don't look like they work right off the bat. We've also got negative y and 4y, so those don't look like they match right off the bat. So we're going to need to multiply at least one of these equations. So here's what I see. I've got negative 1y's on red. I've got 4y's on blue. I'm going to multiply both sides of that red equation by 4. And that way, I'll have the same magnitude of y's on top and bottom. So that gets me 4 times 1.25, and I'll work that out on my calculator. So 4 times 1.25 is 5. So 5x's minus 4y's equals negative 28. In blue, I'm going to keep it the same. Negative 5x's plus 4y's equals 28. And we did that so we have the same magnitude of y's. You might notice that the x's also have the same magnitude. We'll talk about what that means here in a second. But if I'm looking at my y's and I'm saying, okay, should I add or subtract these equations to get rid of my y's? Negative 4y's plus 4y's is how I'm going to get rid of it. So I will again add these two equations. 5x plus negative 5x. That's gone. Negative 4y plus positive 4y. That's also gone. I get 0 on this side. And then negative 28 plus 28, well, that's actually 0 as well. So we get 0 equals 0 in this problem. Now, what does this mean? If you remember from the substitution lesson, we said if we get an answer that makes way too much sense, 0 equals 0, yes, it does, all the time, well, then that means that this is a dependent system of equations. Dependent systems, if you recall from 3.1, have an infinite number of solutions because they are actually the same line. They're actually the same line lying right on top of one another, and so they hit in an infinite number of points. So just wanted to give you an example of what that looks like in elimination. If everything cancels out and we get something like 0 equals 0, then it is a dependent system. All right, so I'm hoping that you've seen elimination before and this is starting to ring some bells. You're following along with the process and feeling okay. What I would like you to do is pause the video and try working this one. Line them up. Figure out if you need to multiply anything, add or subtract the equations, so on and so forth. Once you're done, unpause the video so that you can see if your work matches mine. I'm going to pause mine as well, get my work on the screen, and then when we're both ready, we'll compare answers. All right, we are back. So let's go ahead and see what we got. You'll notice on mine, after putting them into somewhat standard form, I decided to multiply my top equation, my red equation, by 3 on each side so that I got 6y's to match the 6y's on bottom. And then in this example, I had 9x plus 6y equals 27, 2x plus 6y equals 6. I had to ask myself, how am I going to get rid of those y's? Should I add the equations or should I subtract them? Well, 6y plus 6y wouldn't do it. That would just give me 12y's and I'd still have y's. So I decided 6y minus 6y, I'm going to subtract the equations. And something that I want to point out is when I subtract, I have to subtract the entire equation. That's why I always put parentheses there just to remind myself. Really easy mistake to make, to just subtract the first term but not the other ones. So 9x minus 2x equals 7x. 6y minus 6y is gone. 27 minus 6 is 21. That got me to x equals 3. And now that I know what x is, I went ahead and just plugged that x value into my original top equation. 2y equals negative 3x plus 9. Plugged in x equals 3. We eventually get that 2y equals 0. Divide both sides by 2, y equals 0. And then you can kind of see from the calculator, I was checking my work, I used that store function, plugged them in, and everything seemed to work out fine. So x comma y equals 3 comma 0. If you got something different, pause the video, figure out where does your work differ from mine. See if you can find, maybe it was a negative, maybe we didn't subtract the entire equation. But don't just move on. Make sure you can find that out or write it down as a question that you can ask next time we meet. So last problem, and we'll just do this one together. Elimination. This first guy is in somewhat standard form looking. So the D and the F on the left, the constant on the right. The second one, I'm going to add F to both sides. Equals 8. So let's go ahead and maybe make the D coefficients match. So I'm going to multiply the second equation by 3 on both sides, and that'll get me to 6D. So top equation stays the same. 6D plus 3F equals 12. The second equation becomes 6D plus 3F equals 24. And so now I'm ready to eliminate. I matched my 6D and 6D. So to get rid of that variable, I'm going to subtract this entire equation because I know 6D minus 6D is gone. D's are gone. But 3F minus 3F is also gone. We get 0 equals 12 minus 24. 0 equals negative 12. Clearly it doesn't. And so this, kind of like the substitution video, this is an example where if we get something that makes no sense at all, then this is an inconsistent system of equations. There is no possible D and F value that will work for both of these equations, so no solution. So sometimes we'll get this. Sometimes we'll get it 0 equals 0, a dependent solution. But most of the time, with the systems we'll be seeing, you will be able to find an answer. So it's important that you know both substitution and elimination. In some problems, one method is going to be way, way easier than the other. So it's valuable to be versatile and be able to approach problems in either way. Hopefully this made lots of sense. If you had questions on this video, please write them down so that you can bring them up next time we meet. But otherwise, that's all I've got for you for this section. I will see you next time.